Welcome to SciTech Culture with Steve Kern and Ben Warner, where we examine science, technology and culture in the 21st century. Visit our website at scitechculture.com. Hello and welcome to SciTech Culture. My name is Ben Warner and I'm joined once again by my good friend and colleague Steve Kern. How are we today, Steve? This is going to talk about all things, I guess, biological in nature with from the small, medium and large, I guess, that we're going to cover.
Yeah, that's right. It's good to be here as always. And I guess, in the absence of that guy that used to be president, of the US, we've got to talk about science again.
Oh, well,
happy days.
Yeah, let's get back to regular programming. Absolutely. All right, so we've got a couple of topics that we're going to go through, largely, I guess, under the broad sort of theme of human biology, I guess, and its development, etc. But various different things. This first story really caught my eye and I thought was interesting was this baby that was born from a 27-year-old embryo and had broken a record previously set by her big sister. So essentially her embryo was frozen in October 92, stayed frozen until earlier this year, and then basically, the whole process went according to plan, and they've got a healthy baby. And it just kind of, shakes up the notion that, just because it was older didn't mean it could, it had to be discarded kind of thing for not being useful, I guess.
Yeah, true. I mean, look, this is a great story and it's very good news. I want to temper it a little bit with, I'm not sure that embryos are meant to hang around for that long, and let's hope everything is normal and goes fantastically well. But I think increasingly now we're seeing more and more evidence that would suggest that while the genetics or the early development may be normal, we don't know longer term, 40, 50 years into that baby's future, whether or not there'll be any effects of this. So it's great news, but I think you also have to sort of temper it with a bit of caution because there's a lot we still don't know about what this means.
Oh, absolutely. And I think but as a side thing, I guess it kind of demonstrates kind of like, I don't know how you'd put it, pushing, I don't know, the boundaries or whatever it is of what potentially could be done, etc. in this sort of field. There's still a lot to uncover and discover, and also, like you said, the longer term effects potentially that could happen. But it's interesting, I think, from that perspective that it opens the world up a little bit in terms of.
Well, it does, but there's the ethical implication as well that if embryos store indefinitely, why don't we just store a whole lot of embryos today and then nobody ever has to reproduce in the future?
Mm-hmm. A whole different society might emerge.
Yeah, or maybe we just have one genetic lineage from, modern Adam and modern Eve.
Mm. Oh, that'll be a whole other discussion that'll get everyone fired up, I think.
There's a lot of implications to these sorts of things, and they're not always readily apparent. So it's an interesting story. It's one that we should all, think about and celebrate life, of course. But, when we start to, I guess, have these technologies and these capabilities, we also have to remember that there's ethical implications, and there's also long-term implications that we still don't really know a lot about.
Absolutely. Well, staying on that sort of frozen theme, but slightly different story, there was this other one that I saw of Jean Hilliard in 1980. She basically effectively got frozen solid due to happenstance and just what ended up happening. But the fact is that she actually, basically unthawed, or basically thawed out, I should say, after the ordeal. And that was actually a really sort of extraordinary and almost unbelievable set of circumstances. And it might just have been, all the steps were just lucky and, played out the way they did.
Oh, very. And look, there's also a comical angle to the story as well. So it's a very serious story, but remarkably lucky. And it's amazing. It also shows how strong and resilient the human body is. She's actually not the only person to have been so lucky. I think Beck Weathers, who got trapped in the blizzard on Everest in 1996, was left for dead twice, frozen solid. They thought he was gone, and both times he came back from the dead. So if you ever get a chance to read his story, it's amazing. And his recovery is amazing, and he's an amazing guy. But it's phenomenal, and other people have survived as well, falling into cold lakes and having drowned technically for up to 10 minutes. But the really cold water effectively allows their body to go into hibernation, and so when they're pulled out and revived, they come back with totally a normal function, whereas if that happened in a normal scenario, they'd almost certainly have brain damage. So it's a remarkable story, but it goes to show really just how tough humans are.
Absolutely. All right. Well, sticking on, I guess, changing tack, I guess, but sticking to the whole how we developed notion was this other story I saw. I saw it actually in the form of one of those YouTube educational videos, but I also found it in this BBC Earth article about how humans effectively, have lost all their fur. Why did that happen? Given all the other primates still have their fur, and it was an interesting discussion about it. Had to do with potentially migrating to, like hotter environments. We were still required to, hunt for several hours a day. So then obviously, thermal regulation of the body becomes an interesting sort of problem to solve. And what ended up happening is we lose all the fur so that, the skin can breathe and let all the heat out. But then there was also the development of sweat glands and how we happen to have more than, sort of primate cousins as well to counteract this particular issue.
Well, that's right. Look, once again, this is another really good story because the hypothesis is quite sound. What I find really interesting is it really challenges evolutionary theory, because when you actually look at the timeline, and this is talked about in the story, the timelines don't add up for it to have happened. So the reasons, and I think the theory behind why it happened is undoubtedly sound, but the actual timelines for it happening aren't. And I think this, once again goes to show that we just don't know, or there's so much we don't know about evolution. So, while I don't think anyone can really question that evolution has occurred, how it's occurred, we still may have an oversimplified concept of how it's occurred. So I found this fascinating, and, it is true. Look around, every other mammal's covered in fur, not us. So, and we are very different to every other mammal too, I guess.
Absolutely. And I guess segueing off onto our next topic, which we can talk a little bit about more anyway, was to do with this rather what they called a holy grail study, the idea that they've it's a very small group of 34 elderly adults, and scientists claiming that they successfully reversed the biological aging process within them. Basically, it had to do with hyperbaric chambers delivering oxygen therapy, and it had an effect on the telomeres and all that sort of stuff. And it I don't know, it kind of struck me as a great headline. Like if it had been, we've had hyperbaric chambers for years. Oh, how did they not know this? Well, let's all go buy one and have one installed at home, do a 90-minute session every day or something, and we'll live forever, sort of thing. It's a bit ridiculous in a way.
Oh, it is, and I think this is one of those dangers in science communication where the story is factually correct, but the actual implications that they draw are probably about 90% different.
Yeah.
So you're absolutely right. Today, everyone can buy a hyperbaric chamber at home and just pump a whole lot of oxygen in there and enjoy this. And it'll probably stop you aging if you start doing it from about the age of 8. I think the thing is that what they've done in this group of old people successfully reversed, I guess, the deletion of telomeres. So telomeres are, of course, like the little bit of plastic on the end of your shoelaces that stop the shoelaces from fraying. If your shoelaces fray, they become shorter or you get more mutations. And that's effectively what happens in genes. Now, just because you restore the telomeres in somebody that's 80 plus probably means that you're going to improve the replication of their cells, but they're still 80-year-old cells that have probably had about 45 years of serious degradation before there with the mutation. So if what they're trying to say is, well, if you start hyperbaric like treatments in your 20s, you'll probably look and feel a lot younger at 80, which we can't possibly know yet because no one's done it. But if you were to do that, then yes, that potentially, just like meditation, just like eating less but eating the right foods and getting 8 hours sleep a night and being hydrated properly and avoiding drugs and alcohol, probably probably you will find a holy grail for aging. I guess what is really interesting in this, though, is, as you say, is that they've shown that just the oxygen treatment alone will reverse aging. And this ties in with a lot of other stuff that we know. So the older we get, the less efficient our metabolism is at an actual energy level. So effectively what happens for us in cellular respiration is oxygen that we breathe into our blood supply goes into the cells and breaks down glucose effectively. And there's energy from that, and that drives our whole cell cycle. As you get older, that process becomes more degraded and not as efficient. And that's where you get errors, and that's what causes the mutations, et cetera, and that's the knock-on effect. So it doesn't surprise me, to be honest, that having a pure oxygen environment is good for you because, of course, it creates a more efficient environment for your body to respire. So it is interesting, and I think I'm going to go and buy a hyperbaric chamber.
I was about to say that. Just, everyone hop onto Amazon and you'll have one in, with your Prime delivery. You'll get it in the next day or two, and then you can just start lapping up that oxygen in your hyperbaric chamber.
My only worry is it might be 40 years too late.
Exactly. All right. And now our last topic for today, which is probably the all-consuming one. And, it all feeds together with all this sort of stuff in what we're talking about. But this DeepMind AI that cracked 50-year-old problem of protein folding. And that, you can probably speak to more of the detail. What I found interesting was the idea of the application of the AI to try to figure this out, because obviously it's an area of interest that everyone wants to crack, along with a lot of these other topics too. But the idea that you could apply an AI and come up with answers is fascinating.
Well, this to me is way bigger than a computer beating a human at chess or a computer beating a human at Go. I mean, this is amazing. Proteins are incredibly complicated. So it's very easy to know what the constituent amino acids of a protein is, but it's almost impossible to know how they actually fold. And in the past, it's been done with effectively crystallography and X-ray diffraction, and it takes people. Let's just say it takes people a long time to work out how a protein is folded, and that's what gives it its biological activity. The fact that AI could do this is absolutely mind-blowing, because it means, one, that there must be a pattern that we as humans haven't been able to work out, and two, the implications of it are incredible for creating drug delivery or understanding how coronavirus or AIDS works, because we would know what their protein structures are, where the key active regions are, and their mode of action, or indeed their mode of stopping them through vaccines. So this is just mind-blowing that AI can do something as complicated as that so quickly, where humans traditionally have taken years to do a single protein. So,
and it's a good news. It's a good news story for AI as well, because the traditional views of this sort of thing is it's all doomsday dystopian stuff that AI is dangerous, etc. And this is actually a really good story to highlight the opposite, almost, in a way.
I completely agree. This is absolutely probably one of the best outcomes you could ever get from AI, because for health and medicine and we've just been talking about a story about aging. Well, if there was any way to truly reverse the effects of aging, this technology will have something to do with it.
Absolutely.
So, I don't think it's very hard to convey how important this breakthrough is, but it's far bigger than a computer thinking like a human, which has been the traditional sort of focus of AI, or being able to complete a human task. This is where AI can do something that quite clearly to date humans really haven't been able to do except through trial and error.
Absolutely. All right, Steve, we might wrap it up there. And it was good to revisit some science after a while. And I'm sure we'll do some more going forward, because I think, like we said at the top of the episode, I think, the news media culture has changed in the last little while. And hopefully we can, get stuck into a whole more wide-ranging topics compared to what 2020 delivered us.
Oh, you can say that again. I think, 2020 is a landmark year for so many reasons, but let's hope from here on, whatever the new normal is, will be normal.
Yeah, absolutely. All right, so don't forget our website, SciTechCulture.com. You can get all of our links and content there. You can subscribe to our YouTube and Vimeo channels, our RSS feeds, and watch us on any and all of your devices, and we greatly appreciate your visits to our website. All right, so that's it for this episode. We'll catch you next time.